How can you verify the trig equation is an identity? Truly like a puzzle. Trig identity is a trig equation that is true for all domain values. So you have things that are equal to other things that will help you solve things. How's that for mathematical explanation? Okay? So identify the trig function equivalent to the given function. Now, do you remember what this is equal to? 1 over the tangent of theta is equal to, does anybody know? Cotangent of theta. It is. And I'll show you more of that in a second. Is this going to be on the final?
No.
Hey, you said there's
one.
Show you why this is true. Okay? You guys, tangent is the same as sine over cosine, correct?
Yeah.
Hey, tangent's the same as sine over cosine. So if I were to write this like this, sine of theta over cosine of theta, yes? This is tangent, sine over cosine. And if I were to do our little multiply by the reciprocal thing, it would end up being this, cosine of theta over sine of theta. And remember, you saw cotangent at one point, and it's just the flipping of tangent, correct? That's why it's cotangent. Sine of theta over cosine of theta, I just told you, is equal to the tangent of theta. I know this is the warm-up, but apparently you guys don't remember, so that's okay. Secant of theta, what does that go with? Do you remember? Cosine. Yes, it is cosine of theta.
So it's just like the opposite.
It's the inverse, basically. Reciprocal. Cosecant goes with what? Do you remember? Sine. SC, that's how I remember it. SC. Okay? All right, so these identities I will give you on the quiz. You will get these on the quiz. We're going to fill this out right now, and these are the things that you're going to use to solve your puzzle later. Okay, so the cosecant, we just said kind of up here, except in a different way. The cosecant of theta is equal to 1 over the sine of theta. The secant of theta is equal to what? 1 over cosine of theta. And you're going to go back and forth between these things to help you solve stuff later. The cotangent of theta is 1 over the tangent of theta. The tangent and cotangent identities. Okay? This is equal to, we already know, the sine of theta over the cosine of theta. Well, if this is tangent, what's cotangent using these? You just flip them. Yeah. Cosine of theta over sine of theta. Now these are some different things that you've not seen before. We don't have to write anything here. Pythagorean identities. It says the sine squared of theta plus the cosine squared of theta equals 1. It all has to do with the unit circle somehow. Haven't figured that completely out yet, but it's true. I can kind of see it if I think about it in my head. This one also, 1 plus the tangent squared of theta is equal to the secant squared of theta. You're going to use these things, like I said later, to help you solve stuff. Finish the puzzle. 1 plus the cotangent squared of theta equals the cosecant squared of theta. All right, down here, cofunction identities. So if you get something like this, just know that that equals the cosine of theta. Do you have to memorize these? No. You're not going to have to memorize this table. This is equal to the sine of theta. Okay. The printing got a little screwed up on this. Negative angle identities. This says the sine of, in parentheses, negative theta is equal to negative sine of theta. Now you would think this would be the same thing, but it's not. The cosine of negative theta is just equal to the cosine of theta, which is weird. I know. I can't explain it. Someday I will be able to. This one, which kind of makes sense because it's tangent, which is sine over cosine, so it's actually going to be negative tangent of theta. So these things you're going to use to solve stuff. Now, I didn't remember much from my math education as I was going through this, but this I remember doing because I liked it after I started it. I'm like, I remember doing this. Okay. All right. So, given that the tangent of theta is 5 over 12, and theta is between pi and 3 pi over 2, what quadrant is that on the unit circle? Do you remember? It's quadrant 3. So this is quadrant 3, which means it's between 180 and 270, which means that both 5 and 12 are negative. And this is important. So I'm just going to kind of start listing stuff over here. I need, in order to do all these trig values, I need to know opposite, adjacent, and hypotenuse. If they gave me the tangent, which of those two do I know already? Opposite and adjacent. But because it's in this quadrant, they're both negative. Okay? So I need to find the hypotenuse. So I'm going to go back here and I'm going to look at this table. And I'm going to say, which one of these do I need to use to find the hypotenuse, do you think? If I have tangent, this is kind of the hard part, picking out which one to use first. But if I have the tangent, which one of these do you think would help me find the hypotenuse? That's a good question. You probably could. I don't know. We should try that. But for now, I'm just going to tell you, we're going to use this one because we have tangent. And now I know part of secant is the hypotenuse. So I'm going to use this one just for now. And it gets easier picking them out, I promise. So let's just write this down. I'm going to use this. 1 plus tangent squared theta equals secant squared theta. Tracy, if you'd like to do the Pythagorean theorem right now and see if you get the same answer, that's cool. So I'm going to plug in what I know. Okay? I know 1 plus the tangent squared would be 5 over 12 squared equals the secant squared of theta. This looks yucky, but it's not really. If I square both of these, I'm going to get 25 over 144, correct? I need to add 1 to that. I need to add 1, make 1 into a fraction that looks like this. 144 over 144 in order to add them together. Because I have to add 1 and these two together and I have to have a common denominator. Okay? Equals secant squared of theta. This is 169 over 144 equals secant squared theta. I don't want squared, so what do? Square root. So that tells me that the secant of theta is equal to 13 over 12. Now, we have to think about this. One of them is negative, and let's think of, you're getting ahead of me. Secant goes with what? Cosine, correct? Okay, cosine is opposite over hypotenuse, or no, adjacent over hypotenuse, correct? So this is hypotenuse over adjacent, and we know our adjacent has to be what sign? Negative. Okay, so this is actually going to be negative here. The 13 is positive. Okay, that's how I get that, hypotenuse over adjacent. Does it work?
Yeah.
Cool. Okay. All right, so I know my hypotenuse is 13. My hypotenuse is 13. Okay, so now I can fill in all of my trig functions real easily. So the sine of theta is equal to, what's sine equal to? Opposite over hypotenuse, correct? So it's negative 5 over 13. I can tell you why probably the Pythagorean theorem won't work because you're not always going to get these easy numbers to work with. So, but anyway, that's all right. All right, cosine of theta, tangent of theta, we already got that. What goes with sine? Cosecant of theta, secant of theta, and cotangent of theta. So cosine is adjacent over hypotenuse, which is negative 12 over 13. Tangent, they already gave us that, it's 5 over 12. Cosecant, I just flipped sine, so it's 13 over negative 5. Secant, I just flip cosine. And cotangent, I just flip tangent. Okay? So there you go, there's that. So that's finding the trig functions. That's one thing you'll have to do. Another thing you'll have to do is simplify. So here we go. This is where we really start using the other side. We have to think about, okay, look at this. I was given this. Maybe if I change that to something else, it'll help me simplify. So let's look at the other side. What is that equal to? Let's see. If this was given to me on the other side, so let's write it like this and see if it helps me out. Let's just see. Again, like I said, it's kind of weird at first, but once you get going with it. What do I know tangent is? It's what over what? Yeah, it's opposite, but it's also sine over cosine, right? So I'm working with theta here, so let's write that. Let's write, okay, I know that the negative tangent could be the same as negative sine of theta over cosine of theta times cosine of theta. You see where this is going here? How does that help me? What can I get rid of? I can cross these out. And my answer, most simplified, is then negative sine theta. And that's it. Stretch your mind. Okay? All right, now let's look at this. I got to simplify this. Sine of theta plus cosine of theta times cotangent of theta. Huh. Does anybody know what the ratio for cotangent of theta is equal to? It is, which will probably help me get rid of something, isn't it? Okay, so if I write this over like this, the sine of theta plus the cosine of theta times, I'm going to rewrite cotangent as cosine theta over sine theta. And if you don't know that, it's on the other side. Now you're like, yeah, so what? Well, I can see here I'm going to be heading towards a squared. When I head towards a squared, I'm probably going to end up using these Pythagorean identities. So let's just see what happens, okay? No, they don't.
They're both on the top.
They're both on the top, so they don't cross out. So let's do this some more. Sine of theta plus cosine squared of theta over sine of theta. So I just multiplied the tops together. No, because of the addition in between. Meaning, I mean, no. But I have to add these two fractions together. I can't do that unless I have a what? Common denominator. So I have to have sine of theta in the bottom. So I'm going to multiply this whole thing by sine of theta over sine of theta. That's going to give me a common denominator. It's also going to give me another squared, which is probably going to head me towards identity. Okay, let's just see. So now what I have is, I'm going to leave it like this. I'm not going to simplify this yet, quite yet. I can, since they have the same denominator, I can combine these fractions to look like this. Sine squared of theta plus cosine squared of theta all over sine of theta. How does that help me? Kelsey knows. Oh, now wait a minute. Let's look at the back. If I got some squared business going on, is there anything there that helps me? This one right here. Sine squared of theta plus cosine squared of theta equals 1. So I can change my numerator to 1. I have to keep my denominator. And that is all I can do with that. See, it's like a puzzle. I told you. It is.
Wait, yeah,
Oh, you could. Yeah, you can write it like that as well. Okay? You could definitely write it as cosecant of theta if you want to. Okay, let's do another one. This one's really easy. I promise. All right? We got sine of x, cotangent of x, times secant of x. If I change these two to what I'm used to working with, I'm going to keep sine of x here. X is just theta. It's just another way of naming an unknown angle. Doesn't matter. If I change cotangent to what? That has sine in it. What does that ratio look like? Do you remember? If you need to look back here somewhere. Where is it? Yeah, right here. Cosine over sine. Cosine of x over sine of x. That's cotangent. Secant is, does anybody know? As a reciprocal, how would you write it? Secant goes with cosine, correct? So if I wrote it like this, oh, look what's going to happen. Watch. These two cancel out. These two cancel out. What are you left with? 1. See, it's like a puzzle. Isn't that cool?
No.
Okay. We got 2 more little things to do. Are you ready? Okay. Verify that. This is my hint to you. Verify that this is equal to this. Okay? So we got to verify it. Here's what you do. You change one side till it equals the other. Or change both sides till they're the same. But I like changing just one side so it equals the other. Okay? So I'm going to look at this. It doesn't really matter. I'm going to change this side right here to end it up to look like that. That's my goal. I want to end up with this. So whenever I have a tangent or a cotangent or secant or cosecant, probably that's where you start. Okay? So I'm going to keep the sine of theta the same, and I'm going to change tangent to sine of theta over cosine of theta. I don't know. Maybe if I multiply the tops together, it'll help. Let's see what happens. So I'm going to multiply sines together. Sine squared theta over cosine theta. Does sine squared of theta equal anything? Let's look. This is where you kind of have to think about your algebra. I see sine squared of theta here. If I were to solve for that, what would it be equal to? Sine squared of theta would actually equal 1 minus the cosine squared of theta. Oh, isn't that cool? So let's try that. So that's true for all of these. You could rewrite these if it helps you. Okay? So I'm going to rewrite the sine squared of theta as 1 minus the cosine squared of theta. And just as a reminder to yourself, you use the Pythagorean identity here. If you want to write that down, you might not have to. I don't know what to do right now. So since it's a fraction, I think this is one of the harder ones, but it's okay. I'm going to split this up as a fraction. I'm going to say, okay, this part is 1 over the cosine of theta minus cosine squared theta over cosine theta. Remember, my goal is to get secant and cosine. Am I heading there? Do you see it? Is it getting closer? See, secant minus I think I'm there. Let's do one last step. 1 over the cosine of theta is equal to what? Secant of theta. And this simplifies to what? Oh, look at that. It's just like a puzzle. It matches. Let's do one more. Trial and error. But the homework that I did, it's not too bad. I tried all your homework problems. I have them all written out. They're not too bad. Okay. Sine of theta times tangent theta plus cotangent theta equals secant of theta. let's try and make this into the secant of theta. That's what we're going to do. So I'm just kind of draw a line here. I'm going to make this side equal that. First thing I would probably do is rewrite tangent and cotangent. Anytime you see that, that might be a starting point. So don't write too big. Just saying. Tangent is the same as sine of theta over cosine of theta. Cotangent is the flip of that. Okay? Then I'm going to distribute. Try and get some squareds going on. See if that helps me. Using the identities, perhaps. We'll see. So if I distribute, this is what it's going to look like. Sine squared theta over cosine theta. That's my first term. Plus, I don't want to write this all out, so just watch what happens. When you do this times this, what are you left with? Cosine theta. Do you see that? When you do this times this, you're just left with cosine theta. Okay. Okay, what am I doing here? I'm adding what? Two kind of fractions, right? I'm trying to add these things together. I can't do it unless I have a common denominator. Right now, this is over 1. So let's try and get a common denominator. I can see I'm heading towards the identity thing. So what do I multiply this by to get the common denominator? Cosine theta over cosine theta. So here I got a common denominator. You're almost there, I promise. Okay, so then this becomes this. The sine squared of theta over cosine theta plus, can you see where we're going here? It's exciting. Oh, you see it? What does that numerator equal? 1. The numerator, if you think of the identity right here, is equal to 1. So if I put this together and remember the identity, it actually equals this, which is equal to what? Secant of theta. Isn't that nifty? Okay, that is